Here we are today with 17th century physics. I've got two great physicists with me today. I've got Christian Huygens and Sir Isaac Newton, and we're here today to talk about our theories about light. And so, Huygens, if you want to start us off, that would be great.
Well, light acts like a wave. That's it, that's all I got.
What are you? An idiot sandwich?
No, you twit, I'm correct. What's your theory, Isaac?
Light is made up of tiny particles.
You are so idiotic. Are you the idiot sandwich?
Oh God!
We are going to be talking about Young's double-slit experiment. Thomas Young in 1801 performed an experiment to see how light behaved when it was shot through two slits. As you can see, it resulted in this dark light pattern, or wave interference. He proved that light travels as a wave. You can see that when the light went through and was split into these two beams, it resulted in a phase shift that either resulted in destructive or constructive interference. Now to Jen to tell you what those mean.
So, the diffraction pattern that you just heard about from Juliette is actually a result of what we call constructive and destructive interference. And so, on the diagram that we have here, we have our monochromatic light source coming out to hit a screen, and we have labeled the constructive and destructive interference patterns. And so we've got bright, dark, rotating back and forth between constructive and destructive. And so when the waves arrive at the screen and they are experiencing constructive interference, they arrive perfectly in phase with one another. And that's what you can see in the drawing here by the waves being aligned. And this results in their lights showing it brighter because they're essentially being added together when they reach the screen. And then contrary to that, we've got our destructive interference, which appears as the dark spots, and as you can see in the drawing, the waves do not arrive to the screen in phase with one another. And so when they arrive, they're interfering with one another in a contradictory way, and so the lights do not end up being added together and we see a sort of dark spot. And so that results in the pattern that we will show you next.
So this pattern you're looking at right now is the diffraction of light. And so, as shown in the video before, the constructive interference can be seen at the bright spots, and the destructive interference can be seen where we see the dark spots. And these spots are actually what's called relative maxima and minima. The relative maxima is when we observe constructive interference, and this occurs at even multiples of pi. So, where you see the bright spots starting from the center would be 2 pi, 4 pi, keep going in that direction, or the other direction, negative 2 pi, 4 pi, etc. And then similarly for destructive interference, we are observing the minima, the dark spots, which represent odd multiples of pi. So pi, 3 pi, 5 pi, and then also in the negative direction as well.
Just like with light, sound also has this interference wave pattern. For constructive interference, instead of having this bright, it'll be louder. And for destructive, instead of it being dark, it'll be softer. You can see this in our next clip.
Before we end this episode, let's check back in with Huygens and Newton.
Oh, such chums. It turns out that they were both right. In the early 20th century, I demonstrated the wave-particle duality of light. I'm Albert Einstein. And you've been watching Physics in the 17th Century.